Hello everyone, welcome to the session today. Hope you all can hear me. Can you guys confirm once? Am I audible, guys?
Yes, sir.
Okay, that's great. Thanks for confirming. So let us start this session, guys. So I think last time I have given you a small demo on what is GCP and what is data engineering. Today I am going to talk about the real-time topic. So we are going to start with the cloud basics. Okay, so I have divided our course into two segments. Let me gonna tell you here. The very first thing is that, so for example, if I wanted to become a GCP data engineer, I would say, for example, I wanted to become a GCP data engineer. Okay, so there are two ways of it because you can look at it here. One is cloud, one more is data engineering. Okay, you can see here we are going to talk about the cloud basics. First thing, GCP cloud basics. Okay, the second part of it is data engineering tools. So today I am going to start with cloud basics. We are going to start with these cloud basics, guys. First, we will try to understand why we need the cloud platform. What is the difference between the on-premises working model as well as a cloud computing model? So let us try to understand the very basics, because if you don't understand the technology of the cloud, you don't appreciate it. If you try to appreciate the technology, then you will learn a lot more. So let us try to focus on why we need to learn the cloud platform, why we need the cloud, and what is the difference between the on-premises as well as cloud. And then we will jump on to the Google Cloud Platform in our further sessions, GCP introduction, why we learn GCP, opportunities and certifications, interfaces, console walkthrough, GCP locations, GCP IM and admin. So all of these things that we are going to talk about it, guys. Today, as a part of today's session, I am going to talk about why we need the cloud platform, why companies need the cloud platforms. Okay, what if there was no cloud 10 years before, 15 years before, if you go back in time, and how people were working without the cloud platforms? So how was the working culture at that point of time? What was the problems that they were facing, and how cloud has solved those problems? Let us try to understand one by one. Okay, so now let me gonna take a simple example and let me try to give you a very good understanding of what is this one. Okay, let us consider an organization wanted to roll out a new application. Okay, just take an example. There is one company and that company wanted to create a new application for their users. Okay, so what will happen if there was a requirement? The requirement is that the company wanted to create a new application for their users. That is the requirement, right? So for this requirement, let us try to understand how many teams are going to work on in a traditional working model and how the output will be for the end users. Let us try to understand in a traditional working model. Then we will compare the same thing with the cloud computing model, and we will try to understand the benefits of using the computing model. Let us try to understand. So let us consider an organization wanted to roll out a new application. Now whenever they wanted to roll out a new application, the business people will be there. The business comes up with a requirement for the application, and there will be a business analyst will be there, and he will gather the needs from the business and analyzes it and converts that into a set of high level technical requirements, and then he passes that information to the solution architect. What the business will do, sir? The business comes up with a requirement for the application, what kind of an application they want it to do, how it has to be, what is the specification. All of those requirements the business comes up with, and that information will be passed on to the business analyst. Now the business analyst will think about a technical point of view from the business. He will analyze it and converts that into a set of high level technical requirements. and then he passes that information to the solution architect. Now the solution architect is the one who designs the architecture to be followed for the deployment of the application. Okay, so every company, if they wanted to create a new application, the solution architect will try to create an architecture diagram to be followed for the deployment of the application. That may involve, so he will be creating the architecture diagram, right? So that architecture diagram may involve how much of an amount of infrastructure that is needed, what is the specification type, what kind of an application that you guys are building, what is the programming languages that you guys are using, what are the load balancers that you guys are using, what are the front end web server, back end web servers and databases, all of those things. So he will be creating an architecture diagram for the application deployment. He will mention all of these things in a pictorial view so that that looks like a multiple people going to work on that particular thing, so that the application will be created at the end. So solution architect is the one who creating the or designing the architecture to be followed for the deployment of the application. That may involve the infrastructure, specification type, the count of servers, or the front end web server, back end web server, databases, load balancers, everything. Okay, so in a traditional working model, can you guys tell me, in a traditional working model, who has to take care of this entire infrastructure? In a traditional working model, if you are following a traditional working model, the company have to deploy this entire thing in the on-premises environment only. If we are following, if you go back in time 10 years before, how people were working is that if they wanted to create this application, the entire infrastructure has to be available in the on-premises environment only. So they usually call that environment is nothing but a data center. Okay, in a data center, you will be having two types of resources. Physical resources, you will be having it, and virtual resources also you will be having it. Okay, so in a traditional working model, whatever the application that you wanted to deploy, you have to deploy in the on-premises environment, organization's maintained environment. We call it as a data center. Okay, so this would have been deployed in the organization on-premises environment, which would mean making the assets or making use of the assets of the data center itself. Okay, so whatever the infrastructure that he has mentioned, the count of servers, if all of them are already available here, we can directly deploy our code on top of it here. We can deploy our code on top of this data center so that your application is ready. Okay, so when I say an application, there are two ways of looking it. So if you wanted to create an application, there is one thing that is code that the developers prepare. There is one more thing that is infrastructure where that code is going to run. Okay, one is code that developers prepare it. One more is infrastructure where the code has to be deployed. Okay, so here the solution architect will mention how much amount of infrastructure that is required, and the solution architect will also mention how to develop this code also. Now this entire infrastructure is already available in the company's data center. Then this code we can directly deploy it on top of this infrastructure. But if that infrastructure is not available in the on-premises environment, because most of the time it may not be available, right? Most of the time it may not be available. The entire infrastructure required for this new application may not be available here. So what if we require additional hardware? Can you guys tell me what will you guys do? So if can you guys guess it, like if the additional hardware is not available in the data center, what is the solution architect will do? Can you guys guess it? What they have to do? What the company has to do at this point of time? Anyone? So that's where they have to purchase the new hardware, right? If the additional hardware is required, see, whatever the application, so the infrastructure required is already available, then there is no problem. The code can be deployed. If the hardware is not available, they have to purchase it. So that is the reason what the solution architect will do is that solution architect will connect with the procurement team and they will create a request to the vendors team. Okay, so the solution architect will connect with the procurement team connects with the vendors team. Now the vendors team will take days, weeks, sometime even months also for the hardware to be purchased and deliver it to the data center. They have to, whatever the additional hardware that is required, they have to purchase it from online stores or offline stores. They have to deliver it to the data center. This would take lot of time. This would take sometimes days, sometimes weeks, and sometimes even months also it will take. Okay, so that is the reason whenever the additional hardware required in the data center, the solution architect will connect with the procurement team. Procurement team will place a request to the vendors team. The vendors team will purchase the hardware and deliver it to the data center, which would take a lot of time. Okay, once the infrastructure is available at the data center, once the infrastructure is available at the data center, that's where the infrastructure team will come into the picture. That's where the infrastructure team will come into the picture. Now, the very first team, that is field engineers. Whatever the hardware that you have purchased, you have to set into a rack and stack mechanism. You have to set into a rack and stack. So that is the reason the field engineers will take care of the rack and stack. The system admins will take care of the initial configuration of the system, and network admin will configure the network so that all the systems will be available over the network, and the storage admins will configure the storage. The backup admins will configure the backups for the systems. Finally, once the entire infrastructure is set up as per the standards, the application team will come into the picture. Whatever the code that they have developed, they are going to deploy it on top of that infrastructure. That's where they will deploy it here. Your application is available now to the end users. Okay, so this is how in a traditional working model, these many teams working behind the scene. You need to understand the concept of how people were working. You need to understand it. Then only you will appreciate the technology of the cloud. I'm telling you guys. Okay. So if there is a requirement or if a company wanted to roll out a new application, the business comes up with a requirement for the application. The business analyst will gather the requirements and converts that into a set of high level technical requirements, passes that information to the solution architect. Now the solution architect will create an architecture diagram to be followed for the application deployment, and he will mention all the infrastructure details and code development details. If the infrastructure is already available in the data center, then there is no problem. But most of the time, the infrastructure may not be available in the data center. So that is where the solution architect will connect with the procurement team. The procurement team will place a request to the vendors team. Now the vendors team will purchase and deliver it to the data center. Now, whatever the data center, whatever the hardware that is available in the data center may not be directly usable format. So that's where the field engineers will do this rack and stack. System admins will do the system configuration, and network admin will do the network configurations, storage configurations, backup configuration. That's where the application team will deploy. So application team means code developers. They will deploy their code on top of this infrastructure. That's where your application is available now, so that your end user start using your application. So this is how a traditional working model, guys. So in a traditional working model, this is how people are, this is how the companies used to work. Now let us try to understand what is the problem here, sir. I see that everything seems good. Can you tell me, sir, what is the problem here? So let us try to understand the problems. So the very first problem here is that the very first problem here is that slow deployment model. It's because that you see here, if a company wanted to deploy one application, they are taking a lot of time for the application deployment. Because you can see here, if the additional hardware required, they are taking even months also. And field and engineers will take some time, system they will take some time, here they will take some time. So everyone takes a lot of time. If I wanted to scale up my system also tomorrow according to the requirement or demand, again the deployment will take even more time. So that is the reason the traditional working model is a one of the slow deployment model. The traditional working model is a one of the slow deployment model, guys. One more thing is that it is very expensive model. It is because that you need to have a you need to manage all of these people, and these are all salaried people only, and you need to maintain the data center, which is very costly operation. 24 by 7 electricity, 24 by 7 cooling supply, 24 by 7 water supply. So everything is again costly here. So that is the reason managing and maintaining the overall traditional deployment model is very costly. Okay, so it is very costly process, I would say, guys. It's because the overall cost for deployment as well as maintaining it is also very high. So that is also one more thing. And the third point is that the limited automation. We cannot go for the automation. We cannot go for a lot of automation here, right? So the automation is limited here. It's because that, so some aspects can be automated, but whatever the field engineers that they are doing, we cannot automate it. Network admins plugging the networking cables, all of those things we cannot automate it. System admins, so most of the activities here, the vendor stream activity, procurement activity, rack and stack mechanism, most of the activities we cannot be able to automate it. Some aspects can be automated, but most of the aspects cannot be automated. So that is the reason the automation is limited and the deployment procedures are manual and very slow. And one more problem is that in the traditional working model, it is a human error is there. So with so many teams working on so many different tasks, the chances of human error is very high, which results in inconsistency in the environment, which results in the inconsistency in the environment. So this is also one of the major problem, guys, because you see here, the solution team, procurement team, this one. So many teams are working behind the scene on a many different tasks, which leads to the human error, which results in the inconsistency in the environment. One more major disadvantage is that the wasted resources. So this is one of the major disadvantages, that the underutilization of the compute resources. The amount of resources that you are purchasing may not be usable for 100%. Okay, so this is also a wasted resources, that because, so you are buying some 100 GB of the data, but you are only using 20 GB of the storage. Okay, so such kind of a things are going to happen, which we call it as a underutilization of the compute resources. Okay, so this is how, when you are working in a traditional working model, the turnover time varies from weeks to months. That's what we call as a slow deployment model, and it is very expensive model. Limited automation is there, chances of human error is there, inconsistency in the environment, wasted resources. So these many problems are there, guys, I'm telling you. So this is the reason people or the organizations are looking towards a one more alternative solution for on premises or traditional working model, because they are facing a lot of problems here working with the traditional working model. So that's where the cloud platforms came into the picture. That's where the cloud platforms came into the picture, guys. So cloud providers provide you the cloud computing services, so that you don't need to focus on these are all activities. Okay, so cloud provider provides you the cloud computing services. You don't need to have the vendors team, you don't need to have a procurement team. No. You need to have an application development team, because code development is cannot be removed, so it has to be there. See here, So what the cloud providers will do is that they provide you the cloud computing services, which are very useful for the organizations. It's like a ready-made services. Cloud computing services are nothing but a ready-made services, guys. In a simple words, if I have to say, cloud provider is nothing but a, he will provide you the rented services. Okay, rented service. It's like a renting a room. So whenever you rent a room, you have to pay the money. So pay as you go model. Okay, pay as you go model. So what the cloud provider will do is that they provide you the cloud computing service for the rent, so that you use those services and you pay for whatever the services that you have utilized. So now you don't need to worry about creating an infrastructure, because the infrastructure is already provided by the cloud provider. You don't need to do the rack and stack. You don't need to maintain the data center now. No such crap now. So all of these things are provided by the cloud provider itself, so that you don't need to worry about it. Now tell me, so if a application deployment, if I have to do it, the infrastructure can be created where, sir? Where can we create the infrastructure now? Can you guys tell me where can we create the infrastructure now? Yes, we can create the infrastructure in the cloud. So when you create the infrastructure in the cloud, it hardly takes few minutes or few hours. You don't need to even wait for a day also. But when you are working in the traditional working model, if you wanted to create the infrastructure, you are taking days, weeks, sometimes even months also. Okay, so that is the reason when you are working in the cloud computing model, the deployment model is faster. So that's the reason I would say that slow deployment model is not there in the cloud. In a cloud, the deployment model is faster. So the faster deployment will be there. And one more thing is that, so you don't need to maintain this field engineers, no system, no storage, no data center at all, no procurement team, no vendors team. Now tell me, which is costly? Is the traditional deployment model is costly, or the cloud computing model is costly? I would say that cloud computing model is cheaper compared to the traditional working model, because now I don't need to maintain the data center itself, which is a very costly operation. So that is the reason I am removing the expensive also. In a cloud computing model, I am talking about cloud, guys. In a cloud computing model, it is cheaper compared to the traditional working model. And one more thing is that, so when you maybe in our upcoming sessions, we are going to work with the cloud only, then you will get to know this point, that most of the services in the cloud platforms are API based, application programming interface based. So when it is a API based, the automation is very high. You can automate almost all the things in the cloud platforms. So that is the reason when you are working in a cloud computing model, the automation is very high. So this point is also not there. Okay, this drawback is also solved by the cloud computing model. And now tell me, is the teams are very high or less here? When you're working in a cloud computing model, you do not have all of these teams. You do not have all of these teams. When you do not have a multiple teams, the chances of human error will be less, which doesn't relate it to the inconsistency. So that is the reason I am removing this point also, because that drawback is also almost solved. Now, wasted resources. In a cloud, how much amount of resources I need, I will only create that much amount of resources. I don't create it extra, I don't create it less. And one more thing is that the cloud provides you the scalability options also. According to your requirement, if you wanted to scale up and down to meet your demand, you can do that. So that's the reason the wasted resources drawback is also solved in the cloud. So this is how, when you are working on a cloud computing model, when you are working on a traditional working model, you are able to see the difference. Okay, now you are able to see the difference, right? So when you are working in a traditional working model, you have lot of these problems. But when you are working in a cloud computing model, these problems are solved by the cloud itself. So that is the reason. That is the main reason I'm telling you guys, most of the companies are started looking towards cloud platforms itself. Okay, so you have a plenty of these benefits are there. I have only just mentioned 5 or 6 here. Even more than these things are also there. So that is the reason the startup companies, MNC companies, product based companies, any company nowadays started using the cloud only. 70 to 80% of the current companies are started using the cloud platforms itself. Okay, so this is how you can see the difference between the on-premises working model as well as cloud computing model. In a simple words, sir, can you tell me what is the difference between the traditional and cloud? If you ask me, in a traditional working model, in an on-premises working model, an organization managing its own infrastructure to run their code or application. If the organization managing its own infrastructure for the application deployment, then we call it as a traditional working model. So that's what we have seen, right? If the organization managing its own data center, in simple words, then we call it as a traditional working model. If an organization develop, sorry, if an organization is dependent on cloud provider, if an organization dependent on the cloud provider, because the cloud provider delivers the infrastructure as a service to you, so that the company started using this. So if you are following such a kind of a model, then you call it as a cloud computing model. You are working in a cloud computing model. So this is how you can see. Sometimes people will ask me, sir, can you tell me what is mean by infrastructure? An infrastructure can be a servers, it can be a hardware or a software or a networking or a storage. Anything you can call it as. Okay, so in a simple words, guys, so in a simple words, traditional working model means whatever the things that are required for the application deployment, you have to, or your company has to take care of it. Your company has to take care of it. In another words, your company has to maintain its entire data center itself for its own infrastructure purpose. So that is what we call as a traditional working model. In a cloud computing model, if you wanted to deploy an application, your company will create the code. Your company will create the code. Your infrastructure is available from the cloud. The cloud will provide you the infrastructure. So you can deploy your code on the infrastructure cloud. So you don't need to maintain the data center here. You don't need to do all of those stuff that we have talked about, right? The field engineers, the system configurations, network, all of those things are not required here. Okay, so in a cloud computing model, you just focus on the innovation rather than creating the infrastructure. Okay, so this is what we the main difference between the cloud as well as traditional working model. Okay, in a simple words, traditional means cooking food at home. Cooking food at home, guys. Similarly, the cloud means ordering a food at restaurant. Okay, so this is how you have it. So this is how cooking food at home. If you wanted to cook a food at home, you need to take care of all the things: stove, vegetables, rice, preparing all of those things. Ordering food at home, you go to the restaurant, just order it, have it. Right, so this is how you can see the difference between both of them. Okay, so this is the difference between, hope you got some idea about the traditional working model as well as cloud computing model. Any question here, guys? Please raise your hand if anyone have any questions. If anyone have any questions, please raise your hand, guys. Okay, so the concept is not very much important, but having this knowledge is very much important. It's because that, so if you are go and working in the cloud platform, if you do not know how the entire company works, then that will be a problem, right? So if you wanted to understand everything, and if you wanted to make sense of everything, that this diagram gives you a very good understanding of how traditional works, how the cloud works, right? So this is how people used to work 10 years before. Now the people are started working with the cloud. Okay, yep. Okay, so now we have seen the difference between the traditional working model as well as cloud computing model. And I'm going to talk about the Google Cloud Platform now, guys. I'm going to give you an introduction. So I have talked about the cloud computing model, right? So we have talked about the cloud provider. So what we have seen, the cloud provider provides you the cloud computing services. Okay. One of that cloud provider is Google Cloud Platform, sir. One of that cloud provider is Google Cloud Platform. Google Cloud Platform provides you the cloud computing services which are very useful for the organizations to deploy the application, create the application, scale the applications and services in the cloud platforms. What is Google Cloud Platform? The Google Cloud Platform is nothing but one of the cloud provider. So you have cloud providers. Okay, you have cloud providers. One of that cloud provider is GCP. If you ask me one more, sir, AWS. If you ask me one more, sir, Azure. So these are the different cloud providers are there. Okay, so our main focus is on GCP in these sessions, guys. Okay, one of the cloud platform is GCP, and what the GCP will do, they provide you the cloud computing services. Cloud computing services. These services are very useful for the organizations to store the data, process the data, build some application, deploy the code or deploy the application, analyze something. So whatever you want it to do, these services are ready-made services. I was talking about ready-made because you are not maintaining the data center here. The cloud providers maintains all of these things for you, and they provide you the cloud computing services which are very useful for you to store your. So if you wanted to store the data, you don't need to buy a machine. You don't need to buy a machine. You don't need to configure the machine. You don't need to install the operating system. Nothing can be done. You can just go to the cloud platform. You go to the cloud storage and you put your data there if you wanted to store something. Okay, so that is how the cloud computing services works. Almost your effort is reduced to so that you can just focus on the innovation rather than the infrastructure creation. Okay, so that is how the services will be provided by the GCP. Okay, in a definition point of view, GCP is a suite of cloud computing services provided by the Google that offers a range of products and solutions for the organizations to build, deploy, and scale the applications and services in the cloud platform. Sir, can you tell me what are those services it is providing? Sir, it provides you the plenty of services such as compute services, identity and security services, management tools, networking services, big data services, storage and database services, and machine learning services. So it provides you the plenty of these services, guys. And our main focus is on big data and storage and databases because we wanted to become the data engineer. So that's the reason where our focus is on. This will also come into the picture. Okay, IAM also come into the picture. So big data, IAM, storage and database services. Okay. So until here, it is just why we need the cloud platform. We have just completed these things, guys. Let me go here. Okay. So I have just talked about this thing today. And I have given you a good understanding of what is GCP and why we learn GCP in our previous session also. This is our very important. From this one onwards, the regular topics will start. From GCP interfaces onwards, the regular topics will start. And I'm going to give you some brief or some idea about the GCP interfaces today. And maybe in our next session, we will talk about a full-fledgedly. Okay? Yep. Before that, if anyone have any questions, you can ask me. Okay. Okay, perfect. So let me gonna talk about it, guys. Sir, you are telling Google Cloud Platform is providing you this many services. I wanted to work with these services from today onwards, sir. Can you tell me how do I work with it? So let me open the Google Cloud Platform, guys. Okay, let me go to the Google Cloud Platform. So you can see here, you can go. So this is how our interface looks like for the Google Cloud Platform. In our upcoming sessions, I will tell you how to create a free tier account in the GCP so that you guys also can uh, log into your Google Cloud homepage and you can start using it for free. Okay, for free. I'll tell you in our upcoming sessions how we can able to create it. For now, just focus on it here. This is how our interface looks like. You can click on this one. You can able to see here products and solutions. Click on this one so that you will be able to see all the products here. So you have here management services, compute services, storage services, analytics services, networking services. So Google Cloud Platform provides you the plenty of services that we have seen. Sir, I wanted to work with these services from today. How do I work with it? What are the interface methods available to work with these services, sir? Can you tell me? If you ask me, I would say that there are four ways to interact with the GCP services. There are totally four ways to interact with the GCP services. If you wanted to interact with GCP services, the very first method is console. The second method is Cloud Shell. The third method is Cloud SDK. The fourth method is APIs or third-party tools. There are totally four methods are there to interact with the GCP services. As a data engineer, sir, I wanted to store some data. As a data engineer, sir, I wanted to process some data. As a data engineer, I wanted to analyze some data or visualize some data. If I wanted to do all of these activities, I am going to interact with the GCP services, sir. Can you tell me what are the interactive methods available to interact with those services? If you ask me, the very first method is console. The second method is Cloud Shell, Cloud SDK, and third-party tools and all. Let me give you a small brief on all of these things. In our next session, we will even talk about in depth. Let me gonna give you some small idea today, and in the next session, we will talk about more. Okay. So first thing is that the Cloud Shell, sorry, Cloud Console. Just categorizing it. Okay. Cloud Console. One is console. The next one is Cloud Shell. This is Shell. This is SDK, and this is third party tools, right? So third party tools we never use. Okay, we use it but we don't worry much because it totally depends on the requirement. Now look at here, guys. So total we have these many things are there. Let me gonna just give you some idea and I'll close it for the day. Okay, first thing, console is a graphical user interface. It is a GUI. Okay, graphical user interface, guys. It's a graphical user interface. So if you wanted to interact with the GCP services, console is nothing but a graphical user interface. And it is web-based. I would mention this one, web-based, at the top first. So it is a web-based graphical user interface. It is a web-based graphical user interface. Similarly, what is a Cloud Shell? So Cloud Shell is a web-based, but it is a command line interface. I would just mention CLI, command line interface. Okay, so Cloud Shell is a web-based, but it is a command line interface. Cloud SDK, it is a local based, guys. It is a local based, but it is a CLI. It is also a command line interface. Third party tools, it totally depends on that particular tool. Depends on that tool. Okay, we can't. justify. Some tools are web based, some tools are command line, so we can't justify them. Okay, it totally depends on the tool. Now we have a console. Most of the time as a data engineer we will be using these three only, I would tell you. As a data engineer we will be using these three mainly, so that's the reason our main focus is also here only. Okay, so look at here guys. So console, cloud shell, cloud sdk. Cloud console is a web based, it is a web based graphical user interface. Sir, can you tell me, you are saying it is web based, can you show me over the web? So I go here, and whatever you are seeing, right, so this is nothing but a console. You can also see here console.cloud.google.com. This is what is your console. If you wanted to work with cloud shell graphical user interface, it is showing you, you click on it here. If you wanted to create a bucket, you click on it here. It's a what we call it as a graphical user interface. Okay, with your naked eye you are going to look at that particular service, you are going to click it, so that you are going to graphically work with that particular service. So this is what I'm calling as a console. Any service, tomorrow you wanted to analyze the data in the BigQuery, you go click on the BigQuery and you analyze the data using the BigQuery here. Okay, so this is how we call it as a graphical user interface, that is our console. Console is a web-based graphical user interface. That is perfect. Cloud Shell is a web-based but command line interface. So it is also web-based. Sir, can you show me? Here we have the Cloud Shell, guys. Here we have the Cloud Shell. If you wanted to activate the Cloud Shell, click on it here. So this is how your Cloud Shell looks like. When you click on the Cloud Shell, this is how it opens at the bottom. Okay, so it opens the command line terminal. Okay, command line interface, it will, okay, sorry, command line interface, CLI, it will open. Let us wait for 1 minute. So that here via commands you are going to interact with the services. Via commands, there you are going to interact with the services visually. So that I wanted to tell you here. How do you interact with the services here? Visually you are going to interact with the services here, visually, right? Visual interface means visually you are going to interact here. How do you interact with the services here? Via commands. Command line interface means via commands only you have to interact it here, right? So let us wait. See here. Okay, see here. So I wanted to list out the buckets in the console using the cloud storage. So this is how you list out the buckets from the cloud console. Similarly, I wanted to do the same thing. GS util ls. So you will be able to see list out all the buckets from the command line interface also. You can also do the same activity here. See the same buckets. How many buckets you have listed out from the console can be done the same activity from here also. So this is what I'm calling as a cloud shell. A cloud shell is a command line interface. Whatever you are able to achieve it using the console can also be able to achieve it with the help of the cloud shell also. The only difference is that that was graphical user interface. It is like your command line interface. Okay, so that is what it is. It is also available over the web only. Okay, so that is how your second thing. And the third thing, that is SDK, which is local based CLI. Local based means SDK can be installed on top of your local machine. Sorry guys. So SDK I have already installed on top of my local machine. If you wanted to install it, I will show you in our upcoming sessions how do you have to install it. Don't worry about that. Once you install it, this is how it is installed on top of your local machine. Just open it. Okay, so it is installed on top of your local machine. Okay, it's like this one, your WhatsApp you have installed on top of your local machine, right? So if you install a local, WhatsApp can be installed on your mobile phone, can also be installed on laptop as well, right? Similarly, SDK, you have it installed on top of your local machine. If you wanted to log into that, you need to gcloud auth login. You need to do the gcloud auth login. Okay, so copy this link. Sorry, I'm going to copy this link and I'm going to paste it here so that it gets logged in to that particular account, to this particular account, to this particular account I wanted to log in. Yes, you are now authenticated using CLI. That means here you can. Okay, so this is how you can also work from here. GS util ls. It is also what, sir? Command line interface only. Okay, you can also list out buckets from here as well. Okay, so this is how you can work from the SDK. You can work from the cloud shell. You can also work from the cloud console also. So you have totally three methods are there. Most of the time people started using all the things. So it totally depends on the requirement that you are going to work with. Okay, you can work from the console, you can work from the cloud shell, you can also work from the SDK. Okay, so with this one I am stopping the session here for today, guys. If anyone have any questions, you can ask me. I will talk about in-depth console, cloud shell, and cloud SDK in the next session, because there are few more things also we need to talk about these things. Just to give you some idea, I have told you today. Okay, so that you guys get comfortable in the next class. Yeah. Now tell me, guys, if you guys have any questions. With this one, I'm stopping the session here for today, guys. If anyone have any questions, you can ask me. Otherwise, we can wind up the session for today. We have just spoken about these things. We are talking about these things today. Okay. Yep. Any questions, anyone? Yes, Lokesh.
Uh, Hi, sir. I have one doubt, sir.
Yes, please.
This course is completely regarding Google
Correct.
Flow, right? In this course, are you covering
Correct. We are
Databricks,
providing. Yes, we are
Python
providing it.
and SpiceBark also we are covering, right?
Correct. Correct.
Okay, okay, okay.
Okay.
Thank you, sir. That is
Yeah.
clear.
Okay. Sure. Sure. Any other questions, anyone? Okay. So if you do not have any questions, we will wind up the session for today, guys. And if you guys have any questions related to the course or anything, you can connect with our team. They will help you. Okay. Yeah. So we have seen about the cloud overview. We have just started with the GCP interfaces. In a console walkthrough, I will tell you how to create a free tier account in the GCP, which is very useful for you to practice. Okay. Yep. Okay, guys. Thank you all. Have a great day. Bye bye. We'll meet in the next class.